Good afternoon, Jan.
Hi, Michael. How are you doing?
Doing very well. Very well indeed. How was your Christmas?
Um, I've been a lot behind my computer.
Oh,
Actually, it was the only thing I could still do, feeling comfortable. No, of course, we have been celebrating in the family, but I got a little bit a virus. It
yeah.
was not COVID, but coughing like crazy. So
Mm,
if I went walking, everything was painful.
mm.
Uh, if I lie down, I cough like crazy. So just sitting straight behind my computer and programming was doing very well.
Okay, actually, yeah, that's what makes me happy too. So, I guess that
Yeah,
worked out.
but then I saw all your messages coming in from every time you checked in,
Oh, yeah.
and then I was programming VB6 and also a little bit VBA in Excel.
Oh, wow.
Uh, yeah, doing an upgrade of one of my old programs,
Uh huh.
uh, which was a lot behind, so I had to catch up, but I almost finished it. Uh, gonna release it either tomorrow or on Monday. Then next release.
Excellent.
No, but every time I do that, then I realize how much progress
Hmm.
we made. Uh, if
Oh,
you go
yeah.
back to an old ActiveX control, which you have to subclass just to get one or the other message from the Windows
Hmm.
procedure, which is not available. Um, if you look at programming today, um, yeah, it's more difficult on one hand, but it's
Hmm.
much more productive.
Right, yeah.
There's so much more things you can do. Um,
Yeah.
because in VB you could do almost everything, but everything you wanted to do was uh, a trick or something special or
Mm.
um,
Yeah, I do remember when I started my career, I was working in C, and then I learned C++. Um, and And so I remember kind of the transition from C and C++ to Java, and
mhm.
um, and just this huge boost of productivity is like I don't have to think about when to delete. I don't have to chase down memory leaks anymore. It's like, oh my goodness, this is amazing. And then the Java library had all the support for making yeah, um, TCP/IP connections. So like, hey, I can create a connection. I can open a socket, and it's like it's just right there. Versus in C, you had to use these. I mean, it wasn't actually in hindsight, it wasn't really a bad API, but it was much lower level. You had to listen and then well, you open the connection, then you listen because I was on the server side, and then you receive, and then you send, and um, yeah, and so it was like, yeah, you're thinking at a higher level, um, and then yeah, I experienced that again moving to .NET, um, yeah, and yeah, I guess if I think back on it, also the JavaScript front end revolution, moving from jQuery, um, Angular maybe not so much, but yeah, when I discovered React, it was like boom, completely completely better way of thinking about how to construct the user interface.
Yeah. And even what amazes me every time I go back to VB6, I also work then in Source Safe,
Oh
Visual Source
wow.
Safe. Yeah, because I've always been using Source Safe with VB6,
Uh-huh.
so the source code is still there, and I don't want to switch all that to Git.
Yeah.
But in the beginning, I said, Git, it's difficult. It's not working.
Uh-huh.
And now I say, well, why can I not do that in SourceSafe? It's so limiting.
Yes.
Um,
Yes, I completely under. Yeah, yeah, I do remember the first time that somebody tried to teach me Git, and it's like, well, yeah, why do I have to do three things where I used to just do one? Um, so you have to stage it and then commit it and then push it, versus just check it in.
yeah, but in source safe, you really have to work very linearly.
Yeah. Yeah.
And while in Git, you would say, okay, I work a little bit on that, I work a little
Mm-hmm.
bit on that, and you clean up everything afterwards.
Yep.
Check in this, check in that, merge. Um,
Yep.
it's
Exactly.
so much more flexible.
Which is precisely what what we have today. I've got 3 pull requests. I wasn't
Yeah,
I
I
wasn't
saw them
expecting to
coming
have
in.
3 pull requests.
I saw them coming in. I say, oh, it's Christmas. Michael is working, working, working.
Yeah, I was supposed to be working on my course, and I actually have gotten a little bit done on the course. Um,
That's the
so
TypeScript course.
yes, that is TypeScript with React Native.
Because I saw it was not yet there a week
Right.
ago.
Yes. Yeah, I asked for an extension. Yeah, we had some family issues to take care of, so I wasn't able to devote any time to it. Uh, Pretty much during the whole month of November. But then, um, yeah, so I've got an extension through the end of January. Um, so I'm hoping to finish up the module I'm working on right now before going off on the cruise, and then when I get back, um, wrapping up the last 2 and getting that done by the end of January. So it'll still be a tight thing,
Wow.
but yeah,
No,
in the
no,
middle of all that,
knowing you, you will manage to do that.
yeah,
Um,
yeah, I figured out a pretty good workflow with the videos. So so yeah, I can as long as really right now the thing that's taking me that takes so long is the research. I want to put concepts in just the right order so that I can uh, create a tight loop with the learner. So
yeah.
um, so here's the thing that I'm introducing you to. You understand that, and then we're going to get into a demo, and then I'll show you that thing that I just introduced you to. But here's I'll first set up why we want to do that. Um, so yeah, crafting that script is the thing that's taking me the longest right now. Once I get it recorded, yeah, the editing is a pretty linear process. Yeah.
Yeah. I don't know how you do it, but making courses, quality courses like that, it must be very difficult.
Yeah, it's a fun skill. And actually, hopefully, I will be branching that out and doing some live video talking about more conceptual things rather than teaching other people's libraries. I'll actually be doing courses on historical modeling and how to talk to stakeholders using that tool, and then um, you building up from there, how to use Jinaga to implement historical modeling, rather than sticking with the things that people already know. It's like, no, let's go ahead and graduate to a new way of thinking.
That would be fun.
Yeah,
Historical modeling at Jinaga.
yeah.
And you want to do that in the same format like before, the small YouTube videos.
Um,
You
uh,
had
yeah,
YouTube videos like 5 minutes and 10 minutes.
yeah.
Um,
I want to still have those for kind of the drawing people in, um, but what I really want to put together is a school. I want to have longer form courses that are like right now. You go to Pluralsight in order to learn technology, um, and so I happen to be there. But this would be a school. You come to this school specifically to learn historical modeling in Jinaga, and then you start off with a few courses. They're still long form courses, but they're more live video. So similar in format to the YouTube videos, but longer form like the Pluralsight videos, and um, and then have some exercises to go along with them. And once you graduate from that, then it unlocks other courses for you. So I want to kind of mix in the video courses as well as at the higher levels have some instructor-led courses, so that
Okay.
yeah, you can kind of earn your way into. It's like, okay, yeah, I've got the basics down. Now let's actually spend time, and that way, um, that loop with the learner is something real. It's not that somebody could, watching a Pluralsight course, just kind of sit back and watch it keep playing. But with this kind of a school, I really I want you to demonstrate your learning before unlocking the next thing.
That would be great, because Pluralsight, you can just fall asleep and the course
Yeah,
continues.
yeah,
Um, that's something what I miss in video courses.
yeah,
That's nice about these interactive things.
yeah.
Um, if there is something you don't follow, you can ask.
Hmm.
You would register them on beforehand.
Right, right.
Yeah.
Yeah,
Mm.
so I want people to have all the different resources to consume the content in the way that they are going to consume it, and if they're going to be consuming it asynchronously um, at first, then that means they can kind of build up and demonstrate that learning before they get to the synchronous um, modalities. So one of the things that I'm going to be starting with pretty soon is um, a study guide for the art of immutable architecture. And so that'll be for individual readers and book clubs. So it'll be a pamphlet with discussion questions and exercises and kind of a guide through the book and how to study it.
Because I'm always wondering, video sessions, if you have to find something back, like all the book clubs we had now.
Mm-hmm.
Sometimes I say, okay, that we spoke about that. Michael explained it, but
Yeah.
where is it? That's the big problem.
Yeah.
While the book, you can just catch the book. Okay, it was chapter 8, it was chapter 10, it was chapter 4. You can find the information and you still find it.
Mm-hmm.
In fact, the videos, guys, I should summarize them, note down.
Yeah. Yeah. That would
Make
actually be a pretty useful resource then for. Um,
yeah.
that could be part of um, the learning guide. Although I might actually, I might actually just want to go in and re-record, um, smaller discussions of a certain part of the book. So maybe it's this written worksheet, discussion questions you could ask with the rest of the learners at your book club. But then, here's a link to a 5-minute video on that particular topic. Go ahead and watch the video ahead of time, read the book, discuss.
Yeah.
Yeah, that
A little
could be
bit like we
nice.
did in the beginning. Like we did in the beginning.
Yeah, yeah.
It was chapter by chapter.
Uh-huh.
But the problem is always to get people to be
Mm-hmm.
all at the same starting point.
Right. Yeah, so that's why this would be asynchronous. It would just be completely, all of this would be available to a learner to start whenever they're ready to start. And if they're coming in with a group of other learners in a book club, they can all start at the same time.
Yeah.
Yeah. So
Yeah, that would be another fresh start.
yes, but so I would like to go over the code changes that I've been working on. So I really want to get these get these in, and then you can start working with them while I'm off on the boat, and then so we don't have anything hanging when I come back. So let's take a look at the pull requests. So I've got one pull request in Jinaga.JS, and this was the one that we already started looking at, and then 2 in Jinaga.net. So this one is the one that you're working on. but these two here. Um, so
It was with the renaming of some parameters.
it includes some renaming, but yeah, the primary thing here with this inverse optimizations is that I discovered, or I wanted to get into code the rules for which inverses are unsatisfiable and eliminate those from the set of inverses. And then along the way, you see the little X. Along the way, one of the tests failed, and it failed for for the reason that it didn't properly generate the right specification, and so that specification would not invert correctly. So I went back and tried to fix that, and then it's at that point that I realized, okay, the query provider is just getting in my way. So that's where I started this new query provider. So basically, this whole thing here, where we are trying to actually so this is this is even an older diagram, but this part right here, this set of objects, these were intermediate objects generated by the query provider in order to generate, well, in this case it was the pipelines, but later on the specifications. But all of this stuff, I was trying to figure out if it was generating the right thing here, or if it was in this other step that it was failing, and just realized this is way too much. It's not helping me out anymore. So I basically rewrote the query provider so that it goes straight from the link to a specification, and then I could and I showed in JavaScript that was possible. JavaScript doesn't support link, but I created a specification DSL in JavaScript that went straight to specification, and it worked. It made sense. So I was like, okay, let me take some of those ideas, but now that I have link, I'll just implement them a little bit differently. But so now we've got a new query provider. So I did that branch off of the same base as this one. So they are not competing. But yeah, I believe that if I get the new query provider in place, then it's going to resolve that that failure, and I should be able to get them both in. But yeah, then on the other side here, on the JavaScript side, this is the one that we talked about for a bit, and then on the stream a couple of weeks ago, we wrote this. Well, let me see if I can just find the individual commit. It'll be easier to see that way. We wrote this this test. Let's see.
Oh, Michael, but you said now we go directly from link to the specification language.
Yes.
Before, did we still went through that intermediate?
Yes. Yes.
Language,
yeah. So when I went from provider or from pipelines to specifications, I just changed what the intermediate language generated. But but now it doesn't even go through the intermediate language.
Okay.
Yeah. So yeah. First of all, in JavaScript. So on the stream, we wrote this this failing test right there. That that it was testing that the results were notified on the correct observer. So here I'm doing an observer looking at all of the companies, or looking at the company for all of the offices. But then here I create a new office in the empty company. So so this one should not notify that observer because it was the wrong company.
Because that was the bug that you fixed last time.
Yes.
Yeah.
Yep. So so now this only has the one office that the company started with, and that was the fix that I demonstrated really quickly last time. And then since then, I've done a few other things here. So you can now watch for an object to be re-added. So let's jump to the test here. So here's the here's the re-added test. So I am starting with the company looking for offices, and then where not exists an office closed, where not exists the office reopened. So this is the classic restore pattern. Yeah. And then when I watch for them, I'll push them to the offices collection, just their hash, and then return a lambda that removes them from the offices collection. So so yeah, kind of borrowed this pattern from React use effect, where you return basically the destructor. So yeah, notify me of this this office, and then when it is closed, then remove it. So this test is showing that when it's re-added, I'm going to call this method again and put it back into the collection. And so so I've got my my closure here. This is an office closure. So if I start up here at the initialization of the facts, so I've got my company, I've got my my office, and I've got the office closed for. Oh, I'm sorry. I created a new office that I called closed office, and then I created an office closed for that that closure.
Yeah.
So so that means we're initialized with a closed office in the initial state. And so yeah, by the way, this first test is just checking that initial state. So we observe the initialized, and then we just see the office in there because it's that same query. It hasn't been reopened. But then yeah, here after we initialize, we create an office reopened. So we say, okay, that closure goes away, office is reopened, and now it's got the closed office in that collection because it called it a second time. So now you've got the delete restore pattern working with watches in JavaScript.
Okay.
And so then there were a couple of bugs that had to do with even deeper queries. So so like in this one, Yeah. I think I had to go down to like for each office, what's the office's name, and then I wouldn't see that working, and so um, I said, oh, there's a few bugs in there, but so I've got those resolved, and so I believe that at this point I am ready to say that watch for the new specification in Jinaga.JS is ready to go. So I'm going to...
Michael, but how was the watch reacting to the delete and restore pattern before? When you restored it, it didn't notify, or?
Right. When you restored, it didn't notify because it wasn't recursively going down into the the existential conditions.
Okay.
So yeah, and now it is, and so we can continue Jinaga.js from that point. But the really interesting one, I believe, is what I was trying to do in .NET, basically to bring the Jinaga.NET and the Jinaga.js inverse calculations into alignment and make sure that they were both code complete. So these inverse optimizations. To show what this is all about, I want to show you inverses happening in .NET. So here we've got a specification that is it's the office closure thing. This one is not doing the reopen pattern. This is just looking for, give me all of the offices where they're actually, this is looking for a positive existential condition. So give me all the closed offices. So offices where there exists an office closure. Maybe this would be a recycle bin that you could go to say, oh wait, no, not that one, restore it. So when you compute the inverse, then this is going to try to compute two inverses. There are two things that could affect this this particular query. So the first thing is that you get a new office fact. So starting with office, it should compute which company that affects. So that's the first inverse. And then the second inverse is the office closure. So when it sees a brand new office closure, then it walks up the chain, finds the company that that office is in, and it selects the office so that it can add it to the collection. But one of those two inverses is unsatisfiable. And that's because when you first see an office, you know that it's not closed. This is the last thing that you saw. Office closure is a successor, so it can't possibly exist yet. And so that means this first office inverse should we should just eliminate that. I'm not sure why I called it the second inverse in this comment. I think it's the first one that's computed. Yeah, it would be the first one computed. Okay, but it's really the first in that collection. And so you end up with just the, when you see an office closure, then join back to the office, and from there up to the company, select the office, and that's the one that you add to this collection. So to demonstrate all that working, and exactly how that works, there's a really interesting algorithm inside of the inverter that when I talked about the history CRDT a few weeks back, I talked about how inversion happens, and it's like take this specification, pick out the labels, and I just kind of faded away the rest of the specification, rearrange them, and then bring it back. And so waving my hands, that's an inverse. But the way that actually happens is this this method called shake tree inside of the converter, or the inverter. So this is the real magic. So given a collection of matches, and a match is an unknown with a bunch of conditions. So when you look at this, that's a match, and that's a match. So given a collection of matches and a particular label, you find that the match with that unknown, you move it to the top, and then you shake the tree. You let everything else fall down until it's a well-formed tree again. Everything's pointing back up. So we can step through that. Yeah, the inverse test, and show how that works. Okay, so I am starting with these matches. So I actually added to the top of the specification that was input, I added all of the givens as matches with no conditions. So those are not valid final specifications. You couldn't execute them, but by putting them in at the top with no conditions, that means that they're available now. When you shake the tree, they fall down and they gain some conditions. So we've got a label on the company and on the office, and this office has this existential condition on it. So what I'm trying to do first is shake the tree to put office at the top. So office is the label that's coming in. So I want to move that to the top. So it's going to find the matches, and it's going to remove that one and insert it again at the top. So now it is kind of just flipped it over. But now the office match refers to the company, but company is further down. So so I have to flip that around in order to correct it so that everything points up. So I'm going to go through all of the conditions, and then for every path condition, so this one is a path condition, I'm going to invert the path condition and move it to the other match. And then when I do that, now I have gotten the path condition down into the company, and I've removed it from the office. So it used to be up here, and it used to be office up to company, and now it is company
to office.
Yep, down to office. Yep. So so yeah, moved that down, and then I have no other path conditions. I have an existential condition, but it's going to skip over that one. And now it's going to look for.
So here we have this right label.
Yes.
What was it called? Label. You had label left, label right.
Yeah. So so for every given path condition, it only records the right label, because the left label is always the same as the unknown. So it just doesn't even capture that. It yeah, that would be redundant. So yeah, if we take a look at this match right here, Then this match has an unknown. The name is company. And then, well, this one doesn't have any path conditions, but yeah, it just has the existential condition. Wait a minute, no, this one is the path condition, yeah. So the path condition, the label on the right is office. And then we've got roles on the left, and you can see in the immediate window that company doesn't have anything after it. There are no roles on the left. Roles on the right, we've got
Yeah,
company.
that was it. It was not label left, label right. It was the role on the right. Yeah.
Yep. And so that captures the name of that role, which is company, and then the target type, which I will be renaming to predecessor type to match JavaScript. But yep, that is the type of the predecessor company. And so that is precisely the role name and the role type.
Yeah.
So, so any other matches? So now it's looking for any matches that were not the top one, the given that I'm trying to shake the tree. I'm basically holding on to one of the nodes, shaking the tree that now becomes the root, and everything else falls down. So anything, I want this one to end up with no path conditions. But everything else should have a path condition that points up the tree. So as it is now, there are no others that have no path conditions. So if I take a look for those, I will find that this match has path conditions. So it falls out, and that is the end of the matches. So I have shaken this tree, and I've moved office to the top, company to the bottom, pointing back up to office. So now I can eliminate this this top match, turn it back into a given, and I end up with a specification that says given an office, find all the companies. But notice right here, the existential condition stayed with that match. So when I am finished shaking the tree, then I can simplify those matches. There we go. So what I'm doing is looking through each one of the matches and trying to simplify them one at a time. And the things that I'm looking for are any existential conditions that refer to the given that I'm trying to compute, so, or trying to start from. So given an office, look for any existential conditions that assume that that there's a successor to that office. So I'll find a path condition here that has office on the right.
Yeah.
And so when I find such a condition, one that expects a successor to the given, so does this condition, which is the office closure, yeah, so it looks for, yeah, that's it exactly. So it looks to see, does this condition expect a successor? And it's really just looking for this pattern where I see given on the right with no roles on the right. So if we were going up to its predecessors, then those predecessors might have successors, so that'd be fine. But if it's, the given is thing on the right, and then on the left we're looking for something that points back to it, it's like, nope, that would be a successor, and those would not exist yet. So it says okay, yeah, so here we are looking for the existential conditions, and do any of the matches within that existential condition expect a successor? This is actually the case that we're about to hit. And so we see yes. One of the matches inside of that successor expects inside of that existential condition expects a successor. Is that a positive existential condition? Are we asserting that that successor exists? And if so, we return null, which means this match is unsatisfiable. Therefore, the whole inverse is unsatisfiable because every match must be true. If it's not an existential condition, so it's a negative existential condition, then we know that it's a tautology. We know that it's always true. And I haven't actually yet come up with a realistic query in which that optimization makes sense, because we're eventually going to pop this whole match off of the tree. And so far, I've only been able to come up with examples where the negative existential condition stays inside of that root. I can't prove that it always stays inside of the root. If I could, this code could be much easier. It could say, oh, okay, I'm just looking at the root. Yeah, if you see existential, then positive exists, unsatisfiable, negative is satisfiable. So, but I can't yet prove that. So I'm going to keep on looking to see if I can find an example where I get a not exists somewhere else in the tree that refers to the given. And then I can code that test and then show that I can eliminate that existential condition but keep the rest of the inverse. Because I know that condition is always true, so why even bother testing it? Okay, so we say, okay, not satisfiable. And so we come out with a null when we try to simplify that match, which means, okay, this whole inverse is unsatisfiable. And so we skip over adding that to the inverses collection. But then we invert the existential conditions. And so that is going to recursively bring us back to shaking the tree. So we're going to walk through all of the existential conditions that we find in the tree. Or in fact, really just in that top match. Yeah, because it's just looking at that very first match. And saying, okay, let's invert that guy. So we come back around, and now we're trying to shake the tree. And the tree that we're trying to shake right now is this one. So it got a little bit more complicated. We've got 3 matches. And that's because we dove into the existential condition and we found that from this office, we have that existential condition, but let's go ahead and pull those matches out. And so we've got the company, and then we've got the office closure, which we just pulled out. So now shake the tree to bring office closure to the top. So when I learn about a new office closure, what do I do? So first of all, find the match, then move it to the top. And so now I've got office closure at the top. And then I need to take this, this path condition and move it down. So we find the path condition, then we invert it and we move it to the office. So now we have the path condition is no longer. What happened to the mouse? I think my battery might be dying.
I don't see your mouse moving anymore.
There it goes. Okay.
Yeah, I see back.
All right. So yeah, we've taken that that path condition, moved it out of the office closure and down into the office. So now it's there, and we stuck that at the top so that it goes before any existential conditions. And so now it looks like we've got everything in the right order. So office is pointing up to office closure, company is pointing up to company. So the rest of this is going to just verify the order and see, okay, everything is good. Do I have any path conditions in the remaining ones? There are path conditions there. How about the third one? Yes, there are path conditions there. So that means everything is in order. And so we get that inverse. So we filtered out one inverse, and then we produce this second one. And that is what gets us back to having just this one inverse in the collection. So continue that, and everything passes. So yeah, that tree shaking algorithm, that was the big thing, and that's what actually executes the query inversion.
That's the difference with the book that you came up afterwards.
Yep. Yeah. In the book, it's a lot more complicated than that. I mean, that seems kind of complicated, but yeah, if you sit down and work through the proof, it actually shows you exactly what's supposed to happen. So one funny thing about that is, kind of a little aside, the proof shows that you've got these 4 different outcomes from the inverse. At the very top, that first inverse that you come up with is definitely going to add a new result to your specification, to your query. And then once you dive into a negative existential condition, then anything that matches that negative existential condition is definitely going to remove a result, if that result is still in your collection. So you could get multiple removes, but you know that if that triggers, then that thing is no longer supposed to be in your results. So remove it if it exists. But then, as you keep on recursing through these negative existential conditions, you get to a point where you've got, like the restore pattern, you've got a negative on a negative. So this office is closed, and then this office is reopened. When you see that an office is reopened, it may be that you need to add the office back to your collection, or it may be that there's another office closure, and so you wouldn't add it back to your collection. So maybe add means that you need to continue executing the existential conditions. So I started with these, and then similar with maybe remove. If you've gotten down to that depth, then there might be. Actually, I can't think of a realistic example. The proof, it kind of falls out that you would have this maybe remove case as well, but I can't think of a practical reason for it. But yeah, something triggers, and you still have to check other conditions in order to know for sure that if it's in your set, it should be removed. But what's really fun is that the inverse, the inverter, actually ends up with those conditions that it needs to double check in the inverse. those conditions end up in matches further down the tree. So it actually does the right thing. Um, so uh, so even though I started with these enums, I ended up not actually using them. I just treat add and maybe add the same, and remove and maybe remove the same, because by that time I figure out which kind of operation it's supposed to be, I've already performed the extra checks to know that you're supposed to remove or you're supposed to add. So I might actually just go back and factor this back out and just have this be a Boolean. It's just either an add or remove. But that was kind of fun when I saw that happen. Yeah, in fact, yeah, like here the restore pattern, and this is the one that is currently failing on this branch, but the other branch fixes it. The restore pattern demonstrates that condition. So when are we going to add a new office? Well, we're going to add a new office when we see that a brand new office is created. Okay, that one's easy. Find the company, add the office to it. You're going to remove an office when you see an office closure. Okay, that's easy. Find the office, find the company, and then remove that office. So office is the thing that we are always projecting to. And if we look down here, the first one was an add. The second one is a definite remove. But then this third one, this third one is the maybe remove. So when you see an office reopening, then look for the closure that you're basically undoing, and then from there look for the office and look for the company, and that's the office that you might be re-adding to the collection, but only if there does not exist another office closure for that same office where there does not exist an office reopening. So the search for the other office closure just already ended up in there, because that was just an existential condition in the original specification that went along for the ride, and it happens to do exactly the right thing. So it's like, wow, okay, math, it's beautiful, it works. So even though I kept track of the fact that this is a maybe add, yeah, I might go ahead and just call in an add because I've already done the check.
Okay, so the inverses are really optimized now.
Yes, yeah, it gets rid of all of the unsatisfiable inverses. And so that's going to come in handy for the for updating the user interface, but then also it uses this same algorithm when computing feeds. Yeah, exactly. So so now you will subscribe to fewer feeds because, as it turns out, the other feeds don't actually influence your evidence.
And in this feeds, Michael, will from the feed you get really fact by fact, or is it still a fact with its predecessors automatically?
Yeah, you get from the feeds you get tuples. So it's not the individual facts that that triggered it. So, for example, if you were to express interest in this specification, then you would end up with you would end up with these three feeds. That there would just be a feed of office company tuples. And the company would be a bit redundant because you already told it that you're interested in this particular company, but um, but it keeps the tuple together because most of the time it's not redundant. Um, and then you've got a feed of office closure, office company, 3 tuples. So those 3 facts are kept together. So you learn about a brand new office closure, then that consistent set of 3 facts, the office closure, the office, and the company, are bundled into a tuple and put into that feed. And then the last one is the reopening. So there you'll get a tuple of 4 facts: the reopening, the closure, the office, and the company. Yeah, but there will be no feed of, which is the one that we eliminated here. Yeah, actually, did this one eliminate any negative existential conditions because they had successors? I'm losing track, but fortunately the math doesn't lose track. But yeah, so yeah, the tuple, or the feed gives you the tuple, not the individual fact, and that way when you compare that tuple with what you already know, and you say, oh, I don't know about these particular facts, then it can build the graph from those facts up, and then give you that subset of the graph, and then you merge that into your own, and you have all the evidence you need.
So, for example, you have a tuple of 3, then you can check whether each of these facts in the tuple you have already. If, for example, the first one you don't have, you will ask for that fact, or for that fact with its full subtree.
Yes, exactly.
Why the full subtree in that case?
Because I don't know for certain that that you have everything in between. So yeah, there might be, for example, a model where you've got employees of a company, and then there are the projects for that company, and now the assignments. These employees are assigned to these projects, and you're starting with the employee, and you're saying, I'm interested in just my projects, and so you've got all the tasks for that project over here. So if I have a feed that gives me the tasks for the projects to which I've been assigned, if now I just learn about in that tuple that task, then I don't know. I can't prove that you already know about the project and the assignment. So yeah, I have to just give you the full transitive closure and say, okay, this is a complete graph. I know that you can understand this. Yeah, there may be some further optimizations in there. So that might be where Merkle trees come into play. So now there's this negotiation of, I know this much of the graph. Is there more that I'm missing? And a Merkle tree can answer that question.
Because dependent on the structure of your tree, that might be a lot of facts coming in.
Yeah. Yeah, it would be interesting to measure to see how that works out. That is going to cause more round trips. I mean, the full Merkle tree negotiation is several back and forth. So it's a trade-off of latency versus bandwidth. So by sending you the full transitive closure, I am taking bandwidth in order to reduce latency.
Just one big message.
Yeah.
Mhm.
Yeah, but yeah, you're right. There may be uh, situations in which you want to take the opposite trade off.
Let's make it a problem.
Yeah, exactly.
Yeah, we will see that one when we get so far. But that's optimization.
Yep. Very
Yeah,
good.
but
So yeah, that's where we are there. Yeah. So the
now I understand why so many messages came in.
yeah.
Yeah, because it's a big progress.
Yes. Yeah, I think so. Um,
Mhm.
but yeah, then I'll do I'll go ahead um, and bring in the new uh, the new query provider. Bring that in first. Merge that back into the other branch. Make sure that it does indeed fix the test. Then I'll merge that one in, and then I'll get on a boat.
And then I have to believe that you don't bring your computer with you.
Right. Yes.
Yeah.
Yes. I did not even purchase the Wi-Fi plan, so I am going to be completely disconnected from the network.
Yeah. But not thinking about historical modeling, I don't think so.
That is going to be difficult. So maybe I will take my tablet so I can at least um, not yeah, my remarkable tablet. So it's just for writing. It's not for browsing the web. And maybe I'll write a few proofs while I'm on the water. It'd be fun.
Yeah, I think there will be a lot of things coming when you're coming back. New
Mm-hmm.
ideas.
Yeah.
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 So next week you will not be there. The week after you will not be there, but the week after normally you're back.
Yes. Exactly. Yep.
And
So I've already updated the Google Calendar for anybody who's using that to subscribe.
I never looked at it.
Yeah.
And the water is not frozen around there.
No, no, it's
No,
it's going to be quite nice. So
a
yeah,
frozen ocean.
we're going toward the equator, not away from it. So
Mhm.
should be
Yeah,
good.
because I heard on the news that in the US there was a lot of trouble with low temperature snow,
Yeah,
but I think around Texas it should be all right.
yeah. There were still some frozen pipes here. Yeah, it wasn't nearly as bad as it was. Yeah, was it just last year? No, no. Effectively 2 years ago. It was the January of 21 that that we had record lows for many days and power outages. So yeah, we had lots of people with no heat in their house, and then burst pipes when it finally did warm back up.
Yeah, but this time you're saved.
Yeah, yeah, yeah. I'm safe. There still have been a few burst pipes around here, but not nearly as bad.
Mm. Yeah. No, over here it's the opposite. There is almost no skiing because it has been raining.
Hmm.
Not in our place here, but in the mountains it has been raining, and the temperature has been too high,
Hmm.
so no snow anymore. So yeah, the
Uh,
weather is crazy,
that's crazy.
um, but I think it has always been crazy. The difference is today we know it and
Yeah,
we can compare it to the other years.
yeah, yeah. That's true.
Before people, communication is so instantly now,
Mm-hmm.
real time that we know everything immediately, and uh, like before
Mm-hmm.
people were also fighting, but we didn't know about it. Now people are fighting, and we see them killing each other in real time,
Mm-hmm.
uh,
Yeah. So
which
I'm looking forward to not knowing about it, at least for a couple of weeks.
yeah. Sometimes you have to skip the news to be happy.
Mm-hmm.
Um, but okay. Anyway, have a very
Very
nice
good.
trip.
Thank you. Certainly will.
Enjoy, and see you back in 3 weeks' time then.
Yes, indeed. I will see you then.
Okay. And make sure there are not no GitHub pull requests coming in,
Yes, keep me honest.
because that means you have been hacking on the Wi-Fi.
Yes. Yes, and
No.
those would probably be some very
Enjoy,
expensive pull requests.
yeah, and enjoy the trip, and don't think too much about programming this week.
Very good. I will.
Okay,
Right.
I go. And Happy New Year.
Yes, Happy New Year to you, sir.
Okay, bye-bye.
Bye.